Now water, in order to get into the pH, pOH area of this lesson, water, we got to go back and talk about what it's doing. So when water is just mixing with other water molecules, okay, we need to remember that water is liquid and not aqueous. So if it's forming hydronium and hydroxide, which are aqueous, the K constant is going to be just the products, and there are no reactants to put it over because they're not in the right state of matter. So instead of a Ka or a Kb, water is a Kw because it's really neither an acid or a base, it's always acting as both. So the Kw of water is always a relationship between how much hydronium is in the water and how much hydroxide is in the water, which changes with temperature. So if most of the time we're going to be looking at this one, we just assume everything in AP chemistry is at 25 degrees because it makes our lives easier. But notice that the Kw decreases in value as it gets colder and increases in value as it gets warmer. So that means that cold water ionizes less, which makes sense because if your water molecules are moving slower and have less energy, it means they're not going to react with each other as much and turn into those ions. If you heat the water up, you're giving them more energy, you're making them move around, you're making them collide, which means that they're more likely to turn into an ion. But the important thing to remember about this is really just that 25-degree number. At 25 degrees, if we're saying that we think Kw is 1 times 10 to the negative 14, then that means the concentration of hydronium and the concentration of hydroxide are 1 times 10 to the negative 7. And this is an important concept because this is how we figure out pH. pH is a description of how far away the molarity of hydronium is from 1 molar. So the equation that we need to use is pH equals the negative log of the molarity of hydronium. So negative log of 1 times 10 to the negative 7th molar is the reason why water is considered neutral. Now, the thing is that all acids and bases are solutions that are in water. So even if you make a really acidic solution or a really basic solution, there's still going to be water molecules in there turning into hydronium or hydroxide. So that means that all solutions have a pH and a pOH because they always contain hydronium and hydroxide. And the magic number that we use to figure it out is 14. The pH of a solution plus the pOH of a solution is always going to add up to be 14 if we're assuming that 25 degrees temperature. So if we put this into action, just to make sure that we're all caught up on what we have learned so far, if we do a question where we want to know the pOH of a solution with a hydronium concentration of 3.12 times 10 to the negative 4, this is important because hydronium does not directly give you pOH, it gives you pH. There we go. So when we do negative log of 3.12 times 10 to the negative 4, we're going to be answering for the pH of the solution, not the pOH, which is 3.51. So almost the whole information. And then if we remember that pH plus pOH is always going to be 14, okay, then I can just subtract 14 minus 3.51, and you get pOH of the solution is 10.49. Similar question, but different. So if the pH is 11.1, what is the hydroxide concentration? So remember, pH gives us information about hydronium, not directly about hydroxide, but we can get there with this information. So the opposite of negative log. So this one gave us pH, but we need to turn it into concentration so that we can figure it out. Okay, first I'm going to remember pH plus pOH is 14. Ooh, man, no. Is 14. So that means the pOH that we need is 14 minus 11.51, 2.49. But that's not the final answer. We want to know, how does this relate to molarity? So the opposite of negative log is 10 to the negative 2.49, which is 3.24 times 10 to the negative 3 molar. And that is what we were looking for.